In this video, I read and reveal my valuable collection of 90 secret strategies and my overall formula for how I do vibe engineering. I share a PDF I carefully crafted just for you and the wider community, and it's not simply vibe coding. It's a massive leap beyond what you've typically heard through the grapevine in the recent past. I step into the lead software engineer and lead architect roles, and do all the major leaps in judgment, system design and architecture, and overall design goals, and data prep. And then a bot like GPT 5.1, or Grok 4, or Claude Opus 4.5 act as the junior dev, slaving through droll syntax at the terminal at your every diction. Now, I've studied computer science theory, information theory, and software design patterns, off and on for over a decade and a half at this point. So I feel more than confident in my ability to very competently lead in these roles. But even if you have no clue what you're doing, it's totally okay. I've been very successfully figuring this out for a little while, and I have since taken 13 pages of notes that GPT 5.1 turned into an expanded paraphrase 23-page masterclass, directly based off of my context history of fulfilling multiple production grade level projects to a mature working state as multi-thousand plus line code bases. So sit tight and behold. Here is my vibe engineering masterclass reading. 90 unique methods to transform vibe coding into serious vibe engineering. Introduction. Vibe coding emerged as a freewheeling, prompt-driven approach to software development, where you give in to the vibes and let an AI generate code with minimal intervention. In vibe coding, the developer tosses broad requests to an AI, e.g., build a sign-up form, and iteratively tweaks prompts until things just work. The AI effectively becomes the lead developer, while you guide it in natural language. The emphasis is on quick results rather than clean architecture or rigorous practices. The priority is describing what you want via prompts, rather than writing the code line by line. However, what gets you a nifty prototype in vibe coding can crumble at production scale. Enter vibe engineering, a cheekily named but serious upgrade of the workflow. Vibe engineering establishes a clear distinction from vibe coding. It signals that this is a different, harder, and more sophisticated way of working with AI tools to build production software. In essence, vibe engineering means treating AI as a powerful collaborator in a structured development lifecycle, not just a code gen novelty. It's about infusing solid software engineering rigor into the vibes. This masterclass will guide you through transforming casual vibe coding into disciplined vibe engineering. We'll follow a complete development journey with 8 stages, from initial research all the way to reflection, highlighting 90 prompt styles and formats ideal for each step. Along the way, we'll use a mix of practical instruction and metaphor, yes, even a bit of poetry, to capture the abstract mindset shifts involved. By the end, you'll have a repertoire of prompts and techniques to actively steer the AI like an experienced conductor, rather than just jamming with a stochastic parrot. Let's dive into the stages of vibe engineering and turn those loose vibes into real engineering mojo. Stage 1. Research, laying the groundwork. The first stage of vibe engineering is research. This is where you put on your detective hat and gather the raw materials: academic papers, documentation, relevant code snippets, user requirements, and past experiments. Unlike casual vibe coding, which might jump straight into let's just build it and see, vibe engineering starts with grounded context. Think of this stage as preparing the canvas and paints before attempting a masterpiece. You are equipping the AI and yourself with knowledge and reference frames, so the subsequent prompts produce accurate and relevant output. In practice, the research stage involves prompting the AI to fetch and summarize information, compare sources, and even format that information in multiple ways for clarity. It's not just what you find, but how you organize it. Here are example prompt formats and styles to supercharge your research workflow. Academic reference mining. Find 3 recent academic papers on your topic. For each paper, provide the title, a 1-sentence summary of its finding, and a direct quote of a key insight. This prompt gets the AI to act as a research assistant, sourcing credible references and condensing their essence. It ensures your project stands on shoulders of giants, not just on vibes. Detailed summary, bullet points. Summarize the key points of a specific article or documentation in bullet points. Use this to distill lengthy texts. The bullet format forces conciseness and clarity, giving you a snapshot of the material. For example, summarize the official Docker documentation on multi-stage builds in 5 bullet points. Compare and contrast, table format. List the differences between algorithm A and algorithm B in a table with columns for A, B, and a brief comparison note. Tables, or side-by-side bullet lists, can help the AI present comparative research. This is great for evaluating technology choices, e.g. REST versus GraphQL, or library X versus library Y. Exploratory Q&A dialogue. Imagine a conversation between a junior developer and a senior engineer about topic. The junior asks questions to understand it, and the senior provides clear answers. This prompt style generates a dialogue or transcript. It can make dense topics more digestible, as if you're listening to an interview or mentorship session. Code-based browsing, pseudo file search. Suppose you have access to the code repository, name or link. Outline what directories and major files it contains, and summarize the purpose of each component. Even if the AI can't truly browse live code, this prompt asks it to infer or imagine a project structure from context. It's useful when you feed the AI some repository info and want a structured overview. Past experiment review, summary plus analysis. Here are notes from a past experiment. Insert experiment notes. Summarize what was tried, and analyze why certain approaches failed or succeeded. Often you have some prior attempts or logs. This prompt gets the AI to not just summarize, but also provide an analytical angle, e.g., it seems approach X failed due to a memory leak, while approach Y was promising but lacked optimization. Multiple format response. Explain concept first in a brief paragraph, then as a bullet list of pros and cons, and finally give a one-line analogy to real life. This advanced prompt forces the AI to present information in multiple formats in one go. It ensures comprehensive understanding. The paragraph gives detail, the list provides structure, and the analogy offers intuitive grasp. For example, explain the concept of eventual consistency in databases in those formats. The AI might return a rich answer that caters to different perspectives. Snippet extraction with context. I have a code snippet below from an open source project. Explain what it does, line by line, and describe any potential issues. Follow with the snippet in quotes or a code block. During research, you might pull a function from Stack Overflow or GitHub. This prompt has the AI interpret code for you. It's like having the AI read and comment code from elsewhere, which can inform how you design your own solution. At the research stage, don't hesitate to ask for information in creative ways. Want a quick glossary of domain terms? Prompt the AI to generate one. Curious about how a certain function is typically implemented? Have it produce a pseudocode template. Need to recall something you read earlier? Ask for a recap. The goal is to saturate the context with relevant knowledge, so both you and the AI have a shared foundation. Metaphorically, this stage is like a chef gathering ingredients and tasting spices before cooking, or a painter mixing pigments and sketching outlines. You are arming yourself with context and clarity. Vibe engineering starts with knowing the terrain, because once you know the lay of the land, you can guide the AI to build structures that won't collapse at first wind. Research done, let's move to planning our project with purpose. Stage 2. Planning and skeleton. Blueprinting the project. Armed with research insights, Vibe engineering flows into a planning and skeleton stage. Here you switch from explorer to architect. The aim is to define what to build and how to structure it, before diving into coding details. In Vibe coding, one might impulsively start coding from a prompt like, let's build a blog app, go, and see where it leads. In Vibe engineering, however, you chart a roadmap and lay a skeleton first, so the AI has a clear map to follow. Think of this stage as drawing the blueprint of a building. It's much easier to construct when you've planned the floors and beams. Key activities in this stage include defining the project's mission, listing features, mapping out modules or components, and deciding on a high-level file structure. It's also about scope control, preventing the infamous scope creep, where a project grows tentacles of unplanned features. Below are prompt examples and styles to master the planning stage. Mission statement. Draft. Provide a one-sentence mission statement for this project, focusing on the core value it provides. A concise mission statement sharpens focus. For example, the mission of this app is to simplify personal budgeting by intelligently tracking expenses and suggesting savings. If the AI's first attempt is vague, you can prompt, make it punchier and more specific. Crafting a mission with AI helps solidify what success looks like. Feature brainstorm, bullet list. List all major features the project should have in its first version, in bullet points. This prompt yields a feature list. You might get bullets like user login and authentication, profile management, dashboard, with key metrics, etc. It's a starting dump. You can then discuss or trim them. Follow up with, now mark each feature as must-have, nice-to-have, or future expansion, to prioritize and avoid doing everything at once. Short-term versus long-term goals. Comparison. Outline 3 short-term goals and 3 long-term goals for this project, and explain why each goal is categorized as such. This helps maintain perspective. For example, short-term might be implement core authentication, needed for any functionality, whereas long-term might be support third-party integrations, for later scalability. The AI can elaborate justification for each, helping you catch if a short-term goal is actually too ambitious, hinting at scope creep. Module component breakdown. Propose a modular breakdown of the project. Which modules or components should we have? List each module with a brief responsibility description. This prompt forces architectural thinking. For instance, for a web app, the AI might list authentication module, user interface module, database module, API module, etc., each with a one-liner, handles all user login and token refresh logic, etc. It's like drawing boxes for components. You can refine or merge modules based on this output. Generate creative module names. Suggest 5 possible names for the analytics module that deals with user stats. Make them descriptive and a bit catchy. Sometimes a bit of fun in naming can clarify purpose, e.g. stat tracker, insight engine. The AI can be surprisingly good at naming conventions, and a good name can set the tone for implementation. If nothing else, it's a sanity check that your module's purpose is clear enough to name. Skeletal file structure, tree format. Outline a skeletal file structure for the project in a tree format. Include directories and key files with short comments if necessary. This structure, formatted in a pseudocode block or indented list, gives a skeleton to fill in. It's much easier to prompt module by module once you have this map. It also reveals if you're planning too many things at once. A huge tree might mean you're over-scoping. Roadmap outline, ordered list. Draft a high-level roadmap for the project with 3 phases, MVP, beta, and production. Under each phase, list the objectives or tasks. A structured roadmap keeps development iterative and goal-oriented. The AI could output something like MVP, A, basic user auth, B, core feature working for single user, C, basic UI. Beta, A, add secondary features, B, improve UI/UX, C, write tests and docs, production 1.0, A, security audit, B, deploy infrastructure, C, monitoring and analytics. This gives you a time-sequenced plan and ensures you're not trying to boil the ocean in one go. Scope creep check, critique style. Review the following feature list and identify any items that might be out of scope or premature for version 1. Explain why. After listing features, use the AI as a scope cop. It might point out, for example, that implementing a machine learning recommendation engine is overkill for V1, especially if the core is not stable yet. The AI's explanation, e.g., this feature requires extensive data and could distract from building the core functionality first, can reinforce disciplined decision-making. Contingency planning, Q&A. If during development we discover that some risky assumption is false, what is our plan B? This prompt encourages thinking ahead for pitfalls. For instance, if the chosen API provider rate limits us heavily, what's our fallback? The AI can suggest alternatives or mitigation, maybe cache results, or switch to a different provider. Planning for the unknowns is part of an engineer's mindset and reduces panic later. By the end of the planning stage, you should have a clear blueprint, a mission, a list of features, trimmed to what matters, defined modules, and maybe even a notional file layout or class diagram. This skeleton is your guide rail. In vibe engineering, this stage transforms abstract vibes into a concrete plan. You're telling the AI, here's the map, now help me build to spec. It's like moving from a rough idea, I want a house with good vibes, to an actual architectural plan. 2-story cottage, 3 bedrooms, open kitchen, facing sunrise. Now, with plan in hand, we proceed to actually building things in the implementation stage. Stage 3, implementation, from outline to code. With a solid plan ready, it's time to write code, but we'll do it the vibe engineering way, methodically, in sections, and with continuous guidance. In vibe coding mode, one might throw a huge prompt like build the whole app, and watch the AI dump a mix of code. Vibe engineering, by contrast, implements stage by stage, much like constructing a building floor by floor, checking at each step. You become the orchestrator, feeding the AI manageable tasks and context, ensuring consistency across the codebase, like naming and style. Key tactics in implementation stage. Generate clear function and variable names. They are the anatomy of code logic. Pick appropriate algorithms or patterns for each module. Code in sections using the plan's structure, maybe one module at a time or one feature at a time, to avoid context overload. Insert high-level comments or placeholders as signposts, so both you and the AI keep track of the big picture as you go. Let's illustrate with prompt examples, ideal for implementation. Name brainstorming, variables functions. Suggest a descriptive name for a function that does X. Also suggest clear names for its two parameters, a user object and a flag for activation. Good naming is critical for readability and maintainability. The AI might respond with, say, activate user account, user send confirmation, which is self-explanatory. If the suggestion isn't ideal, iterate. The name is a bit unclear. Maybe something shorter or more specific? The model can generate alternatives. Remember, naming is design. Vibe engineering treats it seriously, not as an afterthought. Algorithm selection, Q&A. We need to achieve Y, e.g., sort a list of millions of entries. What's the most efficient algorithm or data structure for this, and why? This prompt makes the AI justify an approach, e.g., use a heap sort because of X, or use a try for efficient prefix search. It's like consulting the AI as an algorithm tutor. You ensure the implementation is built on solid logic, not just whatever the AI first blurts out. For each module, you might ask the AI to recommend patterns, e.g., for user input validation. Should we use a schema library or handwritten checks? Discuss pros and cons. Section by section coding with headers. Instead of code the whole thing, implement the module component name. Start by writing the code for a specific part. Use a big comment header to indicate the section, e.g., input validation section. Then proceed to implement that part. This is a guided prompt that instructs the AI to only focus on one section and label it clearly. For example, implement the sign-up form handler. Use comments to separate validation, database insertion, response. The AI will produce code segmented by these big headers, making it easier to read and review. This approach mirrors how an engineer might outline code first with commented sections and then fill them in. It keeps the AI on track. Incremental module integration. Here is the code for module A, e.g., the data model. Now implement module B, e.g., API endpoints, that uses module A. Only show module B's code, but assume module A's classes and functions are available. Ensure naming and types match. As context windows are limited, we often can't show the AI everything at once. This prompt style feeds in one module's interface or summary, then asks to create the next module accordingly. It's crucial to mention the interface clearly, e.g., assume module A.getUserOpen, parenthesis ID close parenthesis, returns a user object. Now implement module B.get_, user_profile, open parenthesis ID close parenthesis, that calls module A.get_user. This way, the AI doesn't drift or invent inconsistent names. You essentially simulate a multi-file environment by iterative prompts. Refining generated code. Follow-up prompts. After the AI generates a chunk, don't just accept it. Continue the conversation. Explain how this code works step by step. The AI should walk you through its logic. This checks its own understanding and helps you verify correctness. Add comments to the trickiest parts of the code for clarity. The AI can annotate its output. Clear code commentary now saves headache later. Does this function handle all edge cases? If not, adjust it. Challenge the code early. For example, if it's a sorting function, does it handle an empty list? If connecting to an API, does it handle network failures? Always prompt the AI to consider errors and unusual scenarios before you move on. Mid-implementation design. Given the modules we have implemented so far, list them or summarize. Is the overall architecture still sound? Suggest any adjustments if a module's responsibility is overlapping or unclear. Partway through building, have the AI reflect on the design. Maybe you notice some logic in Module A that really belongs in Module B. You can prompt the AI to confirm and even refactor if needed. We'll do more of that in the testing stage, but it's good to be proactive. This is vibe engineering's self-correcting trait. We course correct early instead of plowing ahead blindly. Controlled expansion, scope discipline. The AI might get excited and start adding extra fancy features in the code. If you see it implementing something you didn't ask for, rein it in. The implementation is adding a recommendation engine which is out of scope. Remove that and keep it simple. This prompt reassures scope discipline. Vibe engineering means you, the human, keep the AI on the rails of the plan. If vibe coding is a jam session, vibe engineering is more like conducting a piece with a score. You make sure the AI sticks to the notes. During implementation, maintain a tight feedback loop. You might implement one function, test it a bit, even manually, then proceed. It's a dance. You lead with clear instructions, the AI outputs code, you review and critique, then lead again. You're not just vibing out code. You're actively sculpting it with the AI's chisel. If the research was gathering clay and planning made the wireframe, implementation is shaping the clay onto that frame carefully. Each prompt is a gentle push or nudge to shape the outcome. By the end of this stage, you should have a first-pass code base that aligns with your plan. It won't be perfect. That's what testing and refactoring are for next. But it should be structurally sound and readable, thanks to the disciplined approach. Onward to making sure this creation actually stands up to scrutiny. Stage 4. Testing, refactoring, and debugging. Ensuring resilience. Now that you have code, the real engineering work begins. Verify it, break it, fix it, and polish it. In vibe coding, testing is often minimal. The code is considered done if it seems to work on the happy path. Vibe engineering takes a very different stance. We assume nothing works until proven, and we refine the code through rigorous testing and refactoring. This stage is about turning a functional prototype into a robust, clean solution. Think of it as tempering steel. You've forged a shape in implementation. Now you harden and sharpen it through repeated heating and cooling, testing and refactoring cycles. Key activities here include writing and running tests, or at least defining test cases, systematically hunting for bugs or edge case failures, refactoring messy parts for clarity, performance, and possibly rerunning certain development loops multiple times to get things right. The AI can assist in all these, acting as a tireless tester, debugger, and code quality analyst. Let's see prompt examples. Test case generation. Generate a set of test cases, as code or descriptions, to verify the module function we wrote. Include normal cases, edge cases, and error cases. This gets the AI to think like a tester. For example, if we have a function parse date string, the AI might propose tests, a normal date, 2025-12-01, an edge case, empty string, an invalid format 32/13/2025, etc. If you're coding in Python, it might even sketch out a PyTest function with asserts. This ensures you don't only test the sunny day scenarios. Diagnostic mode, static analysis. Act as a code analyzer. Review the following code for any potential bugs, inefficiencies, or non-best practices. List issues you find. Here you show the AI some code, a function or a module, and ask it to critique. It might catch things like the function doesn't close the file handle, causing a resource leak, or there's a possible off-by-one error in the loop. This is incredibly useful. A fresh set of AI eyes on the code might spot what you missed. It's like having a linter, a security auditor, and a senior dev in one, giving you feedback. Bug hunt with context. If you have a failing scenario, when I input X, the output is wrong. Describe what happens. Where in the code could the problem be? Walk through the code logic with that input. This prompt gets the AI to simulate the code execution with the given input and pinpoint likely failure points. It's akin to a rubber duck debugging session where the AI narrates the code's behavior. Often the act of stepping through reveals the bug, e.g., we never reset this variable between calls. Refactor suggestions, general. Suggest ways to refactor the function module to improve readability and maintainability without changing its behavior. The AI might respond with, extract a helper function for section X, rename variable Y for clarity, use a loop instead of repeating code, add a doc string explaining Z. It gives a to-do list for cleaning up the code. You can then ask it to implement those one by one. Good idea. Please apply suggestion 1 and 3 in the code. Refactor in steps. Specific. For larger changes, break it down. Refactor the process data. Function by splitting it into two functions. Load data and transform data. Show me the new code for those functions and how process data calls them. This instructs a specific refactoring and asks for the code. By controlling the granularity, you avoid the AI messing up unrelated parts. Essentially, you're pair programming the refactor, you propose a strategy, the AI executes it. Edge case checklists. List all the edge cases for a module that we should consider. For each, note if the current implementation handles it or not. This prompt yields a thorough list, e.g., empty input, currently not handled, would crash. Extremely large input, might be slow but should work. Null values, partially handled via default path. The AI may not be 100% correct, but such a checklist is a great starting point to systematically address each case. Then you can take each unchecked case and ask AI to fix it. Modify the code to handle empty input by returning a default value. Automated testing loop. Run through a mental execution of all tests on the code and report any failures or unexpected behaviors. If any, suggest a fix. This is a bit meta, but you can imagine the AI has the tests from earlier. It might say, test 5, empty input, would fail because the code doesn't handle empty string. Suggest adding an if check at the start. It's like the AI is dry running tests. Of course, if you can actually run tests in your environment, do so. But having the AI predict issues can catch things before you even run a single test file. Multi-iteration refinement. Sometimes one pass isn't enough. Embrace iteration. Try rewriting the function in a different way to see if it simplifies the logic. The AI can produce an alternate implementation. Even if you don't use it fully, it might have cleaner parts to merge into yours. We've fixed a few bugs. Rerun the diagnostic analysis on the updated code to ensure all earlier issues are resolved and no new ones appeared. Essentially loop back. Reprompt the static analysis from step 1 on the new code. If something persists or a new warning comes, address it. This could be a quick 5 to 6 times loop. The question even suggests running sections 6 to 12 times with tweaks. Each loop you tighten the code's quality, like sanding wood in finer and finer grain. Failsafe injection. Add failsafe checks or exception handling to make the module more robust. For example, ensure it doesn't crash on bad input or network failures. This direct prompt tells the AI to fortify the code. It might add try except blocks, input validations, fallback defaults, etc., turning fragile code into one that fails gracefully. Always evaluate the suggestions. Sometimes AI might overdo it, or add redundant checks, but it's easier to trim excess than to have missing safety. As you iterate through testing and refactoring, maintain an attitude of constructive skepticism. Assume there's always another edge case lurking, another variable name that could confuse future you, another block that could be simpler. Use the AI to simulate being a devil's advocate. E.g., if you were trying to break this system or find its weaknesses, what would you try? Let it unleash some creative chaos, then fix any vulnerabilities it exposes. This stage might feel less fun than cranking out new features, but it's where vibe engineering really separates from vibe coding. It's the disciplined grind that produces reliable, clean software instead of a flimsy script. Metaphor time. If coding is writing the first draft of a novel, testing refactoring is editing and proofreading. A vibe coder might publish the first draft and hope for the best. A vibe engineer edits ruthlessly, sometimes rewriting chapters, until the story holds water and sings. By the end of this stage, your code should not only work but work well, readable, resilient, and ready to ship with confidence. Stage 5. Documentation and commentary. Narrating the code. Congratulations! Your code now works and is polished internally. But can others or future you understand it without diving into every line? The next hallmark of vibe engineering is excellent documentation and commentary. Whereas vibe coding might leave behind a few cryptic comments or skip docs entirely, after all, the AI knows what it meant, right? Vibe engineering treats documentation as a first-class artifact. A well-documented project is easier to maintain, easier to onboard collaborators, and even easier for AI agents to work on later, since you can feed the docs into context. This stage involves writing clear code comments, generating high-level docs like a README, possibly a changelog, or EULA if relevant, and ensuring all knowledge is captured in human-readable form. You can enlist the AI as a technical writer and commentator. Here are prompts to achieve stellar documentation. Intention comments. Inline. Go through the code and add comments following this convention. Start a comment with intention, and describe what the code intends to do. If applicable, add future intention for planned improvements or fix me, and if the code is tricky, add implementation to describe what it currently does in plain English. Only add comments where it's non-obvious. This prompt defines a commenting style, a custom one using tags as requested. For example, above a complex loop, the AI might insert Xander. Intention. Iterate through all users to find those inactive for over 30 days. Implementation. Currently checking by last login timestamp. Assumes data is pre-sorted by date. By future intention. Optimize by using an indexed query instead of in-memory loop. This system of commenting, intention versus implementation versus future, explicitly separates what the code is meant for, how it does it now, and what could change. It's an excellent way to document not just the what, but the why and what's next. Prompting the AI to do this ensures consistency and thoroughness. The AI can swiftly traverse the code and insert these annotations. Generate README content. Draft a comprehensive README for the project with the following sections: introduction, features, installation, usage, with example, and license. The tone should be professional and helpful. This will have the AI produce a markdown text for README. It should mention what the project is about, introduction, highlight key features or modules, so readers know capabilities, provide instructions to install docs setup, show a basic usage example or code snippet, very important for user onboarding, and mention license or any legal note, maybe a one-liner if not a full EULA. You might get an initial draft that you can then refine with follow-ups. Add a badges section at the top for build status and license. Include a short contributing paragraph, encouraging issues, and PRS. Ensure the installation instructions have both Docker and manual steps. The README is the project's story for outsiders. Vibe engineering ensures that story is clear and inviting, not an afterthought. EULA or license draft. If your project needs a specific license or EULA, generate a simple end-user license agreement, EULA. For this project, written in plain language, it should cover usage rights, liability limits, and not holding the developer responsible for damages. The AI can outline the legalese, though you should have a human legal review if it's serious. Alternatively, summarize the MIT license terms in one paragraph to include in the documentation, if you use a standard license but want to explain it. Docstring generation. For each function in the code, write a clear docstring, 3 to 5 lines, explaining its purpose, parameters, return values, and any exceptions. In-code documentation, like docstrings for Python, or javadoc for Java, can be generated by AI pretty effectively, since it can read the function signature and body to infer details. For example, a Python function, def_add.user_list_user, might get a docstring. Add a user to the user list if not already present. Returns true if added, false if user was already in list. Raises value error if user data is invalid. These docstrings ensure anyone reading the code, or using an IDE with hover docs, gets quick info on how to use each piece. Comment style guide. Application. Rewrite the comments in the code to follow best practices. Use third person, present tense, avoid redundant information. Ensure to-dos are clearly marked and double-check grammar. This is a polishing step. Maybe your AI earlier wrote comments like, "I check if the list is empty," which is first person and not standard. This prompt tells it to apply a consistent style, e.g., check if the list is empty. Also, if some comments are trivial, walk increment I by 1 for I++, we don't need that. The AI might remove or refine them. The result is clean, professional comments. Markdown formatting suggestions. Review the drafted documentation and suggest improvements in Markdown formatting, such as adding code blocks for code examples, using tables for any data, or adding links where needed. The AI can act like a documentation editor. It might suggest, for instance, that in the usage section, you format the example command as bashcode block, or that you add a table of commands versus descriptions if listing CLI options. It could also catch if any heading levels are off, or if linking to an external resource could help, like linking to a dependencies docs. A well-formatted README is easier on the eyes and more useful. Embed diagrams via text if needed. While all examples here are text-based, sometimes you want an architectural diagram. You might prompt, describe the system architecture in words as if painting a mental picture, since we can't include an actual image. Use an ordered list to represent flow if helpful. The AI might output something like 1. The client sends a request to the server. 2. The server's API module authenticates via the auth module. 3. Data is fetched from the database. 4. The server returns the result to client. In a neat textual flow. Not exactly an image, but a structured description that serves a similar purpose. In vibe engineering, documentation isn't separate from development. It's an integral stage. By having the AI help here, you ensure nothing is left undocumented due to fatigue or forgetfulness. Additionally, well-commented code and docs feed back into the AI workflow. If you loop back to coding with these comments and docs available, the AI will use that context to avoid mistakes, like it reads the doc string you wrote next time it modifies the function. Good documentation is a gift to your future self and your collaborators, human or AI. Metaphorically, if the code is the machine, documentation is the user manual, and the signposts on the machine's parts. A vibe coder might deliver a black box. A vibe engineer delivers a transparent box with labels on every gear. This builds trust and ease of handover. Now that we have a solid, documented piece of software, let's consider how it fits into the wider world and how to present it externally. Stage 6. Marketing and ecosystem thinking. Positioning and strategy. Software doesn't exist in a vacuum. Even if you're just coding a hobby project, there's an ecosystem of users, potential contributors, or competing tools around it. Marketing and ecosystem thinking is about stepping back and viewing your project through a product lens. This might sound out of place for engineers, but in vibe engineering, it's acknowledged that understanding the why and for whom of your project influences how you build it. It prevents scope bloat by focusing on what users actually need, and it helps you craft the project's narrative for adoption or collaboration. In this stage, you use prompts to analyze the market. Compare with similar projects, brainstorm use cases, and shape your project's brand, tone, naming, public perception. Here are some prompt techniques. Market analysis, competitor research. Identify 3 existing tools or libraries that solve similar problems to this project. For each, list their name, 1 key strength, and 1 weakness or missing feature. The AI can enumerate known projects in the space. For example, if you built a web framework, it might list Django, Flask, etc., noting things like Django. Very powerful admin interface, strength, but heavy for small projects, weakness. This helps you see where your project might fit in, or what unique value proposition you have. It might also warn you if you're reinventing a wheel that others have polished. Feature desirability. Matrix. Make a table of proposed features versus target user types, e.g. beginner, power user, admin. Mark which user type cares about which feature. This prompt yields something like a matrix where features are rows and user personas are columns with check marks or notes. For instance, CLI interface, power users check, beginners maybe, admin check for scripting. This analysis can highlight if you're building something users actually want. If a feature doesn't light up any persona's interest strongly, maybe it's gold plating. Avoiding scope bloat, critical eye. Given the current feature set and project scope, identify any features that seem like scope bloat, i.e., nice but not essential, and should potentially be cut or postponed. Justify why. The AI might point out that your app's built-in chat feature is cool, but not core to the main function, suggesting this could be dropped for now to focus on the key value, X. Having this external critique keeps the project lean. It's like having a product manager interrogate your roadmap, ensuring you're not chasing shiny objects at the expense of core functionality. Adjacent use case. Brainstorm. List some adjacent or secondary use cases for this project. How might different audiences use it or benefit from it, besides the primary purpose? This can reveal opportunities or needs for extension, or again, things to explicitly defer. For example, if you built a data visualization tool, adjacent use cases might include educational tool for teaching data science, or internal tool for company metrics dashboards. This thinking helps in marketing. Who else can I pitch this to? And in architecture, maybe design it flexible enough to cater to those later. Be careful. This is brainstorming, not immediate action. It's to understand the ecosystem, not to immediately balloon the scope. README tone and branding. Rewrite the project introduction in a more casual and friendly tone, as if speaking to a group of enthusiastic beginners. Tone matters in how your project is perceived. If your initial README draft was very formal, you can have AI try different voices, casual/friendly, or conversely enterprise serious. Another prompt. Propose 3 different taglines or slogans for the project, e.g., for the GitHub repo tagline or website header. Make one humorous, one strictly professional, and one aspirational. For example, serious tagline, Efficient X, high performance data processing made simple. Humorous tagline, Efficient X, we do the heavy lifting, you take the coffee break. You might actually use one of these in your docs or pitches. Community and contribution guide ideas. What steps can we take to make this project appealing for open source contributors? List some ideas, like contributing guidelines, a code of conduct, easy first issues, etc. The AI will likely enumerate good practices for building an ecosystem around your code. Even if you're not open sourcing, thinking this way ensures your code is clean and modular, because if it's appealing to contributors, it's generally well structured. If you are open source, the AI's suggestions can be directly turned into actions, like add a contributing.md with guidelines. Competitive edge. Highlight, from the feature list and design, what are the top 3 selling points of this project that we should emphasize in a blog post or announcement? Frame them in an exciting way. This is marketing spin. If your project is super fast, the AI might phrase a selling point like blazing speed, processes data in half the time of similar tools, meaning you get results in seconds. If it's user-friendly, no fuss setup, one command install and instant results with sensible defaults. This helps when you announce the project or even when you decide which features to refine first. You might focus on making those top selling points truly excellent. Risk and mitigation analysis. Identify any external factors or dependencies that could impact the success of this project, e.g., if it relies on an API or a library that might be discontinued. Suggest how to mitigate these risks. This is forward thinking, e.g., dependency on library X. Risk, X might not be maintained. Mitigation, have a plan to fork or replace if needed, relying on Twitter API. Risk, policy changes could break it. Mitigation, modularize that part so it can be replaced with a different feed. By addressing these in documentation or architecture, you further bulletproof your project. Marketing-wise, you might even mention works offline or no external dependencies as a plus if you consciously avoid risky dependencies. This ecosystem thinking stage essentially aligns your project with reality. The reality of users, competition, and long-term viability. It's easy when vibe coding to tunnel vision on features you personally find cool. These prompts help you continuously ask, does this really matter? To whom? Why? The outcome is a project more likely to be useful and sustainable. Metaphorically, if your project were a product on a shelf, this stage is about designing the packaging and knowing the market. A vibe coder might create a great gizmo, but nobody knows how to use it or why it's better. A vibe engineer makes sure the gizmo has a clear purpose, a label that says, here's why this is awesome, and fits into a toolbox that people actually have. With marketing and context in mind, we proceed to the penultimate stage, reflecting and seeking feedback. Stage 7, reflection and peer review, continuous improvement. By now you have a working, well-documented project that aligns with user needs. It's time to take a step back and critically reflect. No code is ever perfect in one pass. Even after testing and docs, there are always things to learn or improve. In vibe engineering, this introspective stage is crucial. It involves reviewing what's been built, possibly across versions, soliciting feedback from yourself, from others, or even from other AI models, and planning iterative improvements. It's about cultivating an engineer's habit of continuous improvement and humility, acknowledging that there's always a better way or a potential flaw lurking. Here are prompt strategies to facilitate reflection and peer review with the help of AI. Self-assessment. Checklist. Review the entire project and list its strengths and weaknesses in bullet points. Consider code quality, performance, features, documentation, and maintainability. This prompt makes the AI act as an impartial reviewer of your project. Strengths might include things like modular design, allows easy addition of new features, or comprehensive test coverage, provides confidence. Weaknesses could be some functions are too complex, or lacks input validation in a few areas. Seeing this list helps you acknowledge what's good to keep doing that, and what needs work to plan next steps. Version comparison, changelog helper. We have version 0.1 and version 0.2 of the project. Summarize the key changes, improvements, or regressions between these versions. If you've saved earlier snapshots, or even via commit history, you can describe them to the AI. It might output something akin to release notes. v0.2 added user authentication and fixed memory leak in data parser. However, startup time increased due to encryption module initialization. This is useful not only for making a public changelog, but for you to reflect on how the project evolved. Are changes aligning with the roadmap? Any pattern of introducing new bugs while adding features? Solicit critical feedback, no ego mode. As a very strict senior engineer, critique this project thoroughly. Don't mince words. Point out anything that seems poorly designed, risky, or hacky. Then suggest how to improve each issue you find. This is asking the AI to be mean, in a constructive way. Sometimes we need a harsh spotlight to see issues we glossed over. The AI might say, the caching mechanism is bolted on and not well integrated. It feels like a hack. It would be better to design it as a core service, or at least encapsulate it in a class, rather than scattering cache checks all over. Such frank critique can be humbling, but it's better to hear it from an AI now than from an angry user or colleague later. Always follow up. Great, now help implement that improvement for actionable ones. Alternate AI perspective. No rule says you can only use one AI model. Sometimes different models have different opinions or catch different issues. For example, after using ChatGPT for most of development, you could prompt another model like Claude, or an open source model with the same critique request. To another AI, here's the project description.code. Do you spot any bugs or pitfalls? Can you think of a different approach for any part of it? We can't literally show that here, but conceptually, cross-verifying with another AI, or even an automated static analysis tool, is akin to a second peer review. One model might catch what the other missed. Security audit prompt. Perform a security audit of this code. Are there any vulnerabilities, e.g., SQL injection, XSS, buffer overflow possibilities, etc.? If so, describe them and suggest fixes. Security is often overlooked in initial development. An AI can simulate a security expert view. It might flag things like User input is directly concatenated in an SQL query. This is a SQL injection risk. Use parameterized queries or ORM to fix this. Or no rate limiting on login API could be brute forced. Consider adding throttling. These are valuable catches. Even if everything seems fine, double check. Performance audit prompt. Analyze the potential performance bottlenecks in this project. If the data size or user load grows 10 times, which parts of code might become slow or fail? Suggest optimizations or redesigns for those. This forward-looking review has the AI think in terms of big O in system design. It might point out that an O(n)² loop will break at scale, or that using a simple list for lookups is fine now, but a database index might be needed later. You can use this to plan refactors, or at least note them in a backlog. User experience feedback, imaginary persona. Imagine you are a first-time user of this tool. With persona, say a data scientist with minimal dev experience. Describe your experience using it. What is confusing? What is nice? What could be improved in terms of usability or documentation? This is more about the polish and UX of your project rather than code, but it's important for adoption. The AI might respond. As a new user, I found the installation to be straightforward. Good README steps, but I was confused when I tried to use the CLI. The error messages were not helpful when I gave wrong input. Maybe add more user-friendly error messages. These insights help you improve the project's ergonomics. Continuous improvement plan. Based on everything we have so far, list the top 5 items we should tackle in the next version of this project to significantly improve it. This synthesizes all the reflection. The AI might combine earlier notes, e.g. Yummy 1. Refactor caching system as discussed. 2. Add input validation to modules X and Y. 3. Improve test coverage for edge cases Z. 4. Optimize performance of sorting in module A. 5. Enhance documentation with a tutorial or examples. Voila, you have a mini roadmap for vNext, and you can loop back to stage 2/3 with these tasks. Reflection and peer review stage emphasizes that vibe engineering is iterative and never complacent. By seeking feedback, even from an AI that was involved, surprisingly, it can still critique its own output when asked. You foster a mindset of constant learning. It's like after finishing a painting, stepping back to look at it from across the room, maybe asking a friend for their impression, noticing that the colors could be balanced better, and then going back with a finer brush. Or after a dress rehearsal, watching the tape to see where the performance can improve. In software, this stage closes the loop. Each improvement sets the stage for another cycle of research, planning, and implementation if needed. At this point, you've truly transformed an initial just vibe it out idea into a serious engineering endeavor. To cap off this masterclass, let's distill some golden nuggets, overarching best practices to carry with you. Stage 8, golden nuggets and best practices, mastering the vibe. In this final section, we step away from the specific project workflow and highlight meta-level practices, the subtle mindset shifts and clever techniques that differentiate a vibe engineer. These are principles and habits that elevate not just one project, but your entire approach to AI-augmented development. Consider these as the tenets of vibe engineering, the golden nuggets that encapsulate how to think and collaborate with AI effectively. Always read the AI's output, line by line. Treat every line of AI-generated code as if you wrote it yourself. Don't just run code blindly. Prompt yourself if needed. Explain this code back to me to ensure I understand it fully. This internal practice, you can even externalize it by asking the AI to summarize its code as we did, ensures nothing sneaks by you. As a vibe engineer, never assume the AI is 100% correct. Trust but verify, relentlessly. Each line reviewed is a bug potentially prevented. It's like proofreading a contract. The devil's in the details, and you must catch them. Naming is designing. The clarity of function and variable names reflects clarity of thought. If you or the AI choose a poor name, pause and rethink. Is this name conveying intent? Could it be simpler or more precise? You can directly prompt, are any names in this code confusing or non-descriptive? Suggest better alternatives. By doing so, you enforce a culture of meaningful naming. It makes the code self-documenting to a degree, reducing cognitive load later. A vibe engineer knows that naming things well is half the battle in programming. Prompt planning greater than prompt guessing. Don't just wing it with random prompts when stuck. Take a moment to plan your query. Perhaps write a mini outline of what you need and feed that to the AI. For example, instead of "why is this not working?" ask "could the issue be an A or B?" Check A first with these conditions, then B. Guide the AI through a structured investigation. This chain of thought prompting yields better results and mirrors how you'd methodically debug yourself. The best prompts often have a clear structure or pseudocode within them. One task at a time, context is precious. Large language models have limited attention, context window. Feed them too much or ask for everything at once, and results degrade. The best practice is to break tasks. First, just generate the outline. Then, now fill in the first section. Then, proceed to next. Yes, it's slower than a single shot, but it pays off in quality. It's like not asking someone to write an essay from memory on the spot, but instead asking for an outline, then a draft, etc. The AI will follow your lead in chunking work. Slowing down to refactor. Speed is seductive. Vibe coding is fun because you feel like you're making rapid progress. But a vibe engineer knows when to hit pause on adding features and devote time to refactoring. You can literally prompt yourself to do so. Before adding more, let's refactor. AI, suggest any code smells or complexity we should simplify now. By slowing down and cleaning up, you increase your speed long term. Less debugging pain, easier to add features. It's the "go slow to go fast" mantra. In other words, be the tortoise occasionally, not always the hare. Code is a living conversation. Think of your code base as something alive that you continuously dialogue with. It's not a fixed artifact that the AI hands you and you never question. Keep asking the code, via the AI. Code, how can you be better? Where do you feel brittle? Obviously the code won't answer, but the AI analyzing the code will. This mindset, that code can always evolve, means you're not afraid to change things. Vibe engineering is fluid. You might redesign a module mid-flight if reflection shows a better way. Embrace that. AI as collaborator, not oracle. Always remember, the AI is a tool, a collaborator, even a weird digital intern, as one author put it. You are the lead. That means you decide what ideas to accept, what to reject, and how to integrate them. Use the AI's strengths, memory, speed, breadth of knowledge, but apply your judgment. For example, if the AI suggests something that doesn't sit right, question it. Why did you choose that approach? Is there an alternative? Make the AI explain or defend its choices. A true vibe engineer treats the AI like a junior dev, great at grunt work and suggestions, but in need of oversight and mentoring. Document as you go. We highlighted documentation as a stage, but the best practice is to document continuously. A tip: whenever the AI gives a particularly good explanation in a chat about how something works, copy that into your documentation or code comments immediately. Don't lose those insights. Vibe engineering blurs the line between conversation and documentation. Your chat transcript can become the basis of your docs. In effect, you've been writing the knowledge base in parallel with the code. Leverage version control and history. Use Git or other version control religiously. Commit often, and don't be afraid to let the AI see commit diffs and prompts if needed. Some advanced workflows allow feeding diffs for explanation. A fun prompt: summarize the changes between this version and the last commit in plain English. The AI can read a diff and do that. It's a great way to ensure you understand what changed. Also, commit messages can be AI suggested. Write a concise commit message for adding the new caching feature. It might produce "add caching to improve data retrieval performance. Uses LRU cache for recent results." By integrating with version control, you maintain a safety net and a narrative of the project's evolution. Cultivate AI literacy and skepticism. Over time, pay attention to where the AI tends to err. Maybe it often forgets to close resources, or it's overly optimistic in error handling. Develop a sixth sense for AI hallucinations, or mistakes. If something feels off, probe it. Double-check that algorithm. Is it truly O of n log n, or could it degrade worse? Push the AI to validate its own claims. Essentially, learn the AI's patterns like you'd learn a colleague's quirks. This literacy makes you faster at catching issues and guiding prompts. Enjoy the creative synergy. Lastly, Remember that vibe engineering, despite the serious name, is meant to be an enjoyable collaboration. Allow yourself some poetic turns, even in prompts, to inspire creative solutions. For instance, Code Genie, weave me an efficient sorting function as elegant as a ballet. You might be surprised. Sometimes a whimsical prompt can jolt the AI into a different style of thinking. Maybe it will produce a particularly concise solution. Don't do this for mission-critical code, of course, but keep the creativity alive. The term vibe engineering itself reminds us not to lose the spark of creativity and fun even as we add rigor. In summary, the journey from vibe coding to vibe engineering is about combining the best of both worlds. The imaginative, rapid, free-form generation that AI enables, the vibes, with the disciplined, methodical, quality-first mindset of seasoned software development, the engineering. By following the stages of research, planning, implementation, testing, documentation, marketing, reflection, and embracing these golden best practices, you elevate your work from a quick hack into a sustainable project. You've learned to ask better questions, structure the process, and treat the AI as a powerful ally rather than a magic crutch. Each prompt is now a tool in your toolkit, over 60 of them in fact, that you can draw on as needed, from brainstorming research to double-checking a bug fix. As a final metaphor, think of vibe engineering like jazz meets architecture. You still improvise and play with the AI, jazz vibes, but you do so within a strong structure and with an ear for harmony, engineering principles. The result is software that not only works, but sings. Now go forth and build with more than serious vibes. Keep this masterclass as a playbook. And remember, the heart of vibe engineering is continuous learning. With each project, reflect on what prompts and practices led to great outcomes and refine your approach. The field of AI-assisted development is still extremely young, and maybe we shouldn't take ourselves too seriously at first while we figure out the most productive ways to apply these new toolmates. Stay curious, stay critical, and above all, enjoy the journey of creating software hand in hand with your AI partner. Happy vibe engineering!